Hey guys, I thought we would look at some practice problems for the measuring matter unit, or module, I guess. It's like 1.02, I think. A lot of people have been having some trouble, so I thought we would try some practice problems so I can show you sort of the method for solving these. So the way you're going to do this is you're going to go to your lessons. There we go. And we're going to go to matter. And let's go to measuring matter. This is where they have all like those converting units problems that a lot of people are having trouble with. Let's go to page 6, because I believe they're on page 6. There we go. See at the very bottom of this page, of page 6, you got to see this practice sheet. Ooh, there are 16 questions. I don't want to do 16 questions. Maybe we'll just do 8 and we'll do evens. I don't know. Yeah, let's try that. Okay, so let's look at number 2 here. It says convert 7.3 kilograms to the unit dag. Now that's not actually dag, that's I believe decagrams. Okay, so DAG should be decagrams. So we're starting with kilograms, we need to convert it to decagrams. Okay, so the first thing that you should always have when you're doing these problems, and you're totally allowed to have it, is a metric prefix table. I just Googled metric prefixes table, and obviously you're gonna need a bunch. I just chose this one because I think it looked nice. These are all fine, right? This is the same information as here. I just like the way this one's arranged. So, yeah, anyway, so let's see, kilograms to decagrams. Well, here's the thing, a metric prefix table, it'll always show you how to convert between a prefix and the base unit. When I say base unit, I mean, let's say we're talking about meters, right? This shows me how to convert between, say, centimeters and a meter, okay? That's what all these numbers show you. Okay, so for instance, this tells me that there are 0.01 meters in a centimeter. This tells me that there are 10 meters in a decameter. Okay. Now we don't really we're doing grams, but it's the same principle. So what I need to do is I need to take kilograms and I need to convert it into grams, and then I need to take those grams and convert them into decagrams, right? DA. So here's how you're going to do that. Let me just show you another window real quick. Set up my iPad. Yeah. Okay. So, let's see here. So, again, the question is saying, what do we have here? We have 7.3 kilograms. I know I have to convert them into decagrams, right? So, let's just see what we got here. We have 7.3 kilograms. We need to convert them into decagrams. Well, here's the thing. For decagrams, again, the first thing I need to do is I need to convert this into grams, right? The first thing I need to do is convert this into grams. So I know I'm going to have to do some conversion. So I know that there is going to be a conversion factor here. So I'm just going to set that up now. Okay, now I got to figure out what my conversion factor actually looks like. So let's go back to our metric prefixes table. I know right now the first step is to convert kilograms, okay, kilograms into grams. Well, if we look here, according to this table, it tells us, remember what these numbers mean, this tells us that there are 1,000 grams in a single kilogram, right? 1,000 grams in a single kilogram. I don't know why I did that. 1,000 grams in a single kilogram. Okay, so I got to figure out where those numbers go. Does my 1 gram go on the top or the bottom? Or I'm sorry, does my 1,000 grams go on the top or the bottom? Does my 1 kilogram go on the top or the bottom? Here's how we figured that out, okay? You see this thing right there, right? That's kilograms, okay? We don't want kilograms, we want grams. Whatever you're trying to get rid of, and we're trying to get rid of kilograms, okay? That's gonna go on the bottom of your fraction, okay? So for my conversion factor, my kilograms, my 1 kilogram is gonna go down here, okay? And the reason for that is, think about it like math, right? Think about this like a variable that you're trying to get rid of. So like, let's say this were x. Well, in order to get rid of x, I gotta divide by x, right? Anything divided by itself cancels out and becomes 1, and we're trying to cancel out kilograms so that we can get grams. And we know that there are 1,000 grams in a 1 kilogram, so So if we were to do this math, my kilograms would cancel out. Awesome. And I guess I'd be left with like 73,000 grams. Let's see, wait. 1, 2, 3. Well, 7,300 grams. I'm not going to do that just yet, though, because here's the thing. We're not done. Remember, this question is asking us to convert 7.3 kilograms into decagrams. So we're not actually done. We have to take this, and then we have to convert that. Ooh, that's not a very good X. Let's try that again. We have to convert this into decagrams. So I'm going to do one more conversion factor. Okay, one more conversion. All right, and this time I know I'm trying to convert between grams and decagrams. Well, first off, since I know that, I'm just going to set those units up right now, just so I know, right? I know I'm going between grams and decagrams. Now, do grams go on the top or the bottom, right? Are they going to go on the top or the bottom? Well, remember, here's the thing. Since grams, right, is up here, right? Grams is in the top, and I'm trying to get rid of it. I'm trying to cancel it out. I want to divide by grams. So that's how I know that grams is going to go down here. And I'm trying to convert to decagrams, so obviously that goes up here. Okay. Next step is to figure out what numbers go here. All right, so I'm going to go to my metric. I'm going to go to my metric prefixes table. Let's see, decagrams. This tells me that there are 10 grams in a single decagram, right? That's what these numbers tell you. They tell you how many of a base unit are in the prefix. So there are 10 grams in a single decagram, right? 10 grams in a single decagram, all right? 10 grams in a single decagram, in one decagram. And if you look here, right, these grams will cancel out because we had one on the top and one on the bottom. Okay, now we just have to do the math, and I'm running out of room here, so why don't we just start it over here, right? We'll put our answer in this box here. Okay, so I'm going to throw this all in my calculator, right? I'm going to throw 7.3 times 1,000 divided by 10. Now notice I'm not dividing by 1 and multiplying by 1, because remember, in math, if you multiply by 1 or divide by 1, it doesn't really make a difference numerically, so might as well skip those steps. So yeah, 7.3 times 1,000 divided by 10. Or you could think of it as 7.3 times 100. Now, I type that in my calculator, and I get 730. Okay, 730. So I'm going to write that down. I'm going to write it in green because it's the right answer, right? 730. And I'm not just going to put 730 because that number means nothing unless I pair it with the unit of measurement. And what is the unit of measurement? It's decagrams, all right? It's dag. So I'm going to always remember to write that. Okay, so that's number 2. All right, let's try another one. Let's do number 4 here. Convert 1,450 milliliters to the unit, what is that, decaliters, I think? Maybe not. Maybe it's deciliters, actually. Yeah, deciliters. My bad. All right, so that's not too hard. So again, same idea, right? The only way we convert between prefixes is to go through the base unit. So what I mean by that is we're starting with milliliters. We need to first, I know it didn't say it here, but we need to first convert that to liters and then to deciliters. So it's going to be a 2-step conversion. All right, so that's okay. So let's just do that here. Let's start with, I've already forgotten the number. What is it? 1,450 milliliters. 1,450 milliliters. I might use a smaller marker this time. Let's see. Ooh, that doesn't look very good, does it? Let's see. 1,450. No, I hate that. 1,450 milliliters. And I know I'm going to have to convert this into deciliters, but first I have to convert it into liters. So I'm going to set up my conversion factor. Oh, nice flat line. And well, the first thing is I know that milliliters has to get canceled out. So I know milliliters is going to go down here because, again, when you divide something by itself, it cancels out, right? X divided by X is 1. 5 divided by 5 is 1. So milliliters goes on the bottom. I'm converting this into, eventually I'm converting into deciliters, but the first thing I have to do is just convert it into regular liters. So I'm going to do that. That's a bad L. Okay. Now, I know my conversion factor, but I got to figure out which numbers go here, right? I got to figure out, well, how many liters are in a milliliter? And I'm going to go to my metric prefixes table. So my base unit, right? That's so in this instance it's liters, right? And I'm trying to figure out how many are in a milliliter. There are 0.001 liters in a milliliter. Okay, 0.001 liters in a milliliter. Or you can think of it as, I guess, 1,000 milliliters in 1 liter, but I'm just gonna do it as they show me. So again, I know that there are 0.001 liters in a milliliter. Okay, there are 0.001 liters in a milliliter. So great, that's step one. I'm not done here because even though my milliliters are going to cancel out, it's not going to give me my answer because remember, the question is asking not for liters, but for deciliters. So let's keep going. We got to figure out how to convert this into deciliters. So I'm going to do one more of these. Okay, I'm converting to deciliters. And again, remember, whatever you're trying to cancel out goes on the bottom, right? We don't want liters anymore. We want deciliters. So I'm trying to get rid of liters. So that goes on the bottom. And I want deciliters. So that's going to go on the top. All right, deciliters is going to go on the top. So that's easy. I already have my units. I just got to figure out which numbers go here. So I'm going to look at my metric prefixes table. So according to this, in a deciliter, there are 0.1 liters. Okay, there are 0.1 liters in a deciliter. All right, there are 0.1 liters in a single deciliter. All right, so my math will check out, right? That will cancel out. And if you'll notice, my final end result, when I do this math, whatever math I do, the final value is going to be in deciliters. So that's great. I'm going to do my math. I don't really have much room up here, so let's set it up down here. All right, let's throw this in a calculator. We got 1,450 times 0.001 divided by 0.1. And I get 14.5. Okay, I get the number 14.5, assuming I put that in my calculator. So 14.5, and it's not just 14.5, it's 14.5 deciliters, okay, deciliters. All right, there's your answer. Woo! Well, actually, let's check. Let's check and see if it is the right answer, huh? Otherwise, I'll feel quite foolish. Hey, look at that, 14.5 deciliters. And I don't think we checked our other answers, so hey, 730. That was right, too. Okay, great. So we're off to a good start. Why don't we try number 6? Okay, number 6, convert 2.5 meters cubed to the unit millimeters cubed. Now this one might be a little bit tricky because we're dealing with volume, okay? Well, but that's all right. Let's start with what we got, right? We got 2.5 meters cubed, okay? So 2.5 meters cubed, okay? I'm trying to convert this into millimeters cubed, okay? So, okay, well, first off, let's just look at, let's look at our conversion. So first off, I've got meters here, right? I got meters here. So I'm gonna put meters down here, and I'm trying to convert it to millimeters. So I'm gonna put millimeters up here. And then let's look at our prefix table. Millimeters is 0.001. So, okay, this is telling me that there are 0.001 millimeters, I'm sorry, 0.001 meters in 1 millimeter. Okay, there are 0.001 meters in 1 milliliter. So 0.001 meters in 1 millimeter. Now, we're not done here because here's the thing. We set up relatively, we set up the conversion factor. But here's the thing. This isn't just meters right now, right? This number, or this unit of measurement is not meters. It is cubic meters, okay? There are 2 more dimensions to this unit of measurement than just length, right? It's length, width, and height. So this conversion factor that I have right here, it's actually not going to cut it because we need to make sure that this conversion factor is also cubed, okay? So what I'm going to do is I'm going to do something kind of weird looking. I'm going to take this whole thing. Why'd that happen? I'm going to take this whole thing and I'm going to cube it, okay? And what is that going to do? If I were to cube this, well, it's going to do a few things. It's going to change my numbers a little bit, and it's going to make sure my units of measurement are correct. Okay. Here's what I mean. I'm just gonna show you what that looks like, right? I'm gonna show you what this looks like. When I do this, when I cube this value, what's gonna happen is instead of 1 millimeter, it's 1 millimeter. Well, it's 1 millimeter times 1 millimeter times 1 millimeter. So that would be 1 millimeter cubed. Okay. Now the bottom is going to be a little bit weird. So because if you think about it, if this is cubed, right? So this denominator here, it's going to be 0.001 meters times 0.001 meters times 0.001 meters. And as you can probably guess, that's going to be a very long decimal that I don't really want to write down just yet. I'd rather wait till the calculator puts it in for me. So what I'm going to do is I'm actually going to keep that in parentheses. I'm going to just write that as, if I could, just write this as 0.001 meters cubed. Yeah, I'm not going to change that just yet. I'm not going to do the math there yet. The math up here was super easy, right? Because 1 times 1 times 1 is still 1. And then millimeters times millimeters times millimeters is just millimeters cubed. But this would get me a very long trail of zeros, and I just don't want to write that down right now. We will do that math in the calculator. Okay, but if you look here, I want you to notice something. This is going to be meters cubed, and this is also meters cubed. So this will cancel out here, right? This will cancel out. Yeah, looks good. So yeah, let's do this math. Okay, so it's going to essentially just be 2.5 divided by, okay, it's going to be divided by 2.5 divided by 0.001 cubed, okay? It's going to be 0.001 cubed. All right, and you're going to get a pretty big number. I'll write it out. See if I have room to write it out. You're going to get this number that should be like, oh gosh, let's see, 2, 5, and then how many zeros do I have? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's what I get on my calculator. 1, 2, 3, 4, 5, 6. Yeah. Okay. So, as you can imagine, that's a lot of zeros. Whew, that's like, what, 2.5 billion? That's crazy. Okay. Well, not just 2.5 billion, right? 2.5 billion millimeters cubed. Okay. 2.5 billion millimeters cubed. I think the problem probably wants us to express that in scientific notation. So why don't we do that real quick? Let's express this in scientific notation. The book should tell you how to do that, but just in case you don't remember, the way you express scientific notation is, first off, you basically create a little decimal point. Sometimes it's already there if it is a decimal, but sometimes it's not. So I'm just going to create a decimal point here at the end. And what you do is you basically see how many times you need to move this decimal point until your number is a number between 1 and 10. Here's what I mean by that. I'm going to keep going 1, 2, 3, 4, 5, 6, 7, 8. Ew. Sorry about that. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. If I put a decimal point right there, what would this number change to? I believe it would change to just 2.5, right? 2.5. And ask yourself that, is 2.5 a number between 1 and 10? It is, right? Nothing else would work. If I brought that decimal 1 over, that'd be 0.25. That wouldn't work. If I didn't bring it all the way over here, like let's say I stopped it here, well, that would have been 25, and that's not between 1 and 10. Here, this would have been 250. That's not between 1 and 10. So by moving this decimal point to the left 9 spaces, I've created a number between 1 and 10, which is 2.5. But here's the thing. These numbers here, okay, these numbers actually do need to equal each other, because the whole point of scientific notation is to make sure that the number equals, like, the number you're, like, the whole point of scientific notation is to ensure that this number up here equals this number down here. The only thing is you're just trying to express it in a simpler way. So basically the next step is to be like, okay, well, 2.5. Let's do 2. You're always going to put times 10 to a certain power in scientific notation, always. And that power is just going to be how many spaces you move the decimal, okay? Sometimes it's a negative number, sometimes it's a positive number. It depends on whether you're trying to express a very large number or a very tiny number. This is clearly a large number, right? This is a number that is greater than 1. So obviously, this is going to be a positive power because otherwise this would express it as a decimal. So we move this over, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. We moved it over 9 times. So guess what? We're going to express it as 2.5 times 10 to the 9th power millimeters cubed. And my God, I hope I got this right because I don't want to have to do this again. Let's see. Oh, look at that. 2.5 times 10 to the 9th power meters cubed. Hey, hey, how about that? That's awesome. Okay, let's try another one. Okay, let's look at number 8. It says if a box has the dimensions of 1.5 meters by 2.3 meters by 1.2 meters, A, find the volume of the box in meters cubed, and then convert the volume to the unit milliliters. Okay, convert the volume to the unit milliliters. All right, so first off, this part's pretty easy. A is pretty easy. Volume is just length times width times height. Well, they give you that. They give you your length and your width and your height. Okay, these numbers right here. All you have to do, and this is super easy, all you have to do is multiply these numbers together. Okay, you're just going to do 1.5 times 2.3 times 1.2. Okay, 1.5 times 2.3 times 1.2. You should get 4.14. Okay, you should get the number 4.14. I don't know if this book is a stickler for significant figures, but they might be. It might be 14.1. Let's just see. Nope, they gave us 14.14. Okay. Now you'll notice it's not just 14.14. It's 14.14 meters cubed because you're multiplying meters by meters by meters, right? So that's meter times meter times meter. Well, that's meters cubed. Just like 4 times 4 times 4 is 4 cubed, or x times x times x is x cubed. So our value is going to be, and that's probably what we're going to start with, is going to be 4.14 meters cubed. And that's the answer to A. Ooh, this marker looks kind of beefy. Let's try that again. 4.14 meters. Yeah, that looks better, doesn't it? Meters cubed. Not much better, but whatever. Okay, and I know I'm trying to convert that into milliliters. Now that's kind of weird, right? Because we're going from, it feels like we're going from length to volume, but we're not, because volume is expressed as, it can be expressed in liters or meters cubed. So all we need to know is, what the conversion factor is between my video cutout. All we need to know is conversion factor between meters cubed, or cubic meters, and milliliters. So I put that right here. I already put it in my Google, right? So if you're ever uncertain, you can always just throw it in there. 1 cubic meter equals, what's that, a million? Right? 1, 2, 3. Yeah, I think that's a million. 1 cubic meter equals 1 million milliliters. So let's set that up. Okay, we're going to put down our... Actually, this will probably have to be longer because that's going to be a big number. Okay, so again, conversion factor right here. Let's put our cubic meter. Where do you think it's going to go? Do you think meters cubed is going to go on the bottom or the top? The trick is to look right here. Remember, we are trying to cancel out meters cubed and express our answer in milliliters because that's what the question's asking, right? Convert the volume into milliliters. So let's do that. Sorry. Okay, so meters cubed, I want to get rid of it, so it's going to go on the bottom, right? My meters cubed is going to go on the bottom, and I'm trying to convert this all into milliliters, so that's what's going to go on the top. ml, it's going to go on the top. And again, we got our conversion factor right here, right? 1 cubic meter equals 1 million milliliters. So 1 cubic meter equals 1 million milliliters. You could also just express this as just like 10 to the 6th power if you wanted to, but whatever. Let's just express it as a million. So a lot of zeros there. But if you'll notice, everything cancels out. We're left with milliliters. Looks like I don't have to do anything else. So let's just do the math. 4.14 times a million. 1, 2, 3, 4, 5, 6. So that's what, 6 zeros and a 1. And I get a relatively big number. I get, let's put this in black. Let's see, 4, 1, 4 and then 1, 2, 3, 4 zeros. 1, 2, 3, 4. So what? That's 4,140,000 milliliters. And again, they might want you to express that in scientific notation. So let's just do that. Again, the trick is just to create a little decimal point. If it's if it already has decimal, just start there. But we'll just create a little decimal point, and we're going to drag it 1, 2, 3, 4, 5, 6. We're going to drag it 6 places over, because that would give us the number 4.14. And 4.14 is definitely a number between 1 and 10. Okay, obviously these numbers have to equal each other, and 4.14 does not equal 4,140,000. So we need to slap on our times 10 here, and it's going to be times 10 to the, how many spaces do we go? 1, 2, 3, 4, 5, 6. So it's going to be 10 to the 6th power milliliters. I sure hope I got this right. Hey, look at that. Oh, looks like they did 2 steps here. I wonder why they did that. Maybe. Okay, so it looks like the book did a sort of a roundabout way. It looks like they converted to centimeters cubed first and then converted to milliliters. I guess you could do that, but if you look here, the answer is kind of the same. I don't know why you wouldn't just use. I looked through the book and I didn't see anything specifically telling you that this is the conversion you have to use. But I mean, you'll see, right? The math does check out, right? Meters cubed cancels. You're left with centimeters cubed. Then centimeters cubed cancels, and you're left with milliliters. And the math is the same. So whichever way you did it, whether this is the way the book showed you or the way I showed you, you will get the same answer. That's the beauty of math. Is there's so many ways to approach a problem. Okay, so let's look at number 10 here. Convert 780 centimeters per second to the unit meters per hour. All right, so this one might be a little bit tricky because it looks like we have a lot of units of measurement we have to work with. But let's just set it up like we would any question. Let's start with the information we're given and write it down. We have 780 centimeters per second. So I'm going to write that down. 780 centimeters per second. And I'm going to write this down a little bit differently. I'm going to write it like this. I'm going to write it 780 centimeters per 1 second. It's the same thing. I just like to write it down like that because it helps me organize my thoughts. Because it helps me really be acutely aware that centimeters is the unit that's in the top in the numerator and seconds is in the denominator. And that's really going to help out in a second, and I'll show you how. So the thing is, we know that we have to convert centimeters to meters, right? Because this question's asking us to convert it centimeters per second to meters per hour. Well, centimeters and meters are length, and seconds and hours are time. So let's just start with our length. Let's start with centimeters and meters. Let's convert centimeters to meters. Okay? And then we'll worry about time afterwards. So I'm trying to get rid of centimeters and find meters, right? Well, I need to make sure that centimeters gets canceled out. Since centimeters is on the top here, right? Centimeters is on the top. I need to make sure centimeters goes on the bottom. And right, because that way it'll cancel out. And since I'm trying to convert to meters, that's going to go on the top. Okay. Always start with what you're trying to cancel out. That'll basically inform the rest of your decisions for the problem. So anyway, let's look at our metric prefix here. Let's see how many meters are in a centimeter. There are, again, the way this prefix table works, it tells you how many of your base unit are in the prefix. So if we look at centimeters, that tells us that there are 0.01 centimeters in a meter. Okay, I'm sorry, there are 0.01 meters in a centimeter. Sorry about that. There are 0.01 meters in a centimeter. So let's write that down. There are 0.01 meters in a single centimeter. Okay, great. So if we were to do that math, and my X looked better. If we were going to do that math and my centimeters would cross out, I'd be left with meters. And then if we put all this together, because we still have these seconds here, that would be meters per second. I don't want meters per second, though. I want meters per hour. So we got a few more steps. The next step is, so we can pretty much ignore meters now. The rest of our math is going to be worried about figuring out how to get seconds into hours. And it's not actually that tough because you know these conversions already and deep down in your head since since you were a little baby. You know how to convert between seconds and hours. You can convert between seconds and minutes and then minutes and hours, right? How many seconds are in a single minute? It's 60. Okay, so you can convert between seconds and minutes pretty easy. So we're going to convert between seconds and minutes. Now, we got to figure out which goes in the top, seconds or minutes. Well, again, think about it very carefully. Right here we have seconds. I need to cancel this out, and I notice it's in the denominator. It's in the bottom. So if this is in the bottom, do seconds go in the bottom or the top? It's going to go in the top, and here's why. If I were to put seconds in the bottom and do this multiplication, that would be seconds times seconds if I were to put it in the bottom. And that would give me seconds squared. Gross. But with seconds in the bottom and seconds in the top, that cancels it out. Like if this were 5 in the, if this were like 1 over 5 and this were 5 over 1, right? That would cancel out. Always think about it like math. How would it cancel? And I'm trying to convert to minutes, and since seconds is already up here, that tells me that minutes is going to go down here. I know that there are 60 seconds in a minute, so that's pretty easy. We're not done though, right? Because even though seconds will cancel, which is nice, we're not looking for minutes, right? We're looking for hours. So we got to do one more step. We got to convert this now into hours. Well, there are 60 minutes an hour, so that's pretty simple. My minutes is going to go up here, again, because denominator, numerator, right? You got to always write it so that it cancels. So my minutes goes on the top, and my hour goes on the bottom. And I know that there are 60 minutes in an hour. Now, if you look here, let's look at everything that cancels out, and let's look at what doesn't cancel out. Because if we look at what doesn't cancel out, we'll be left with hours and meters. Meters in the top, hours in the bottom, so it'd be meters per hour. And that's what we're looking for, right? Our question asks us to convert all this into meters per hour. So if I do this math, it'll all work out. So what kind of math are we doing here? It's going to be 780 times 0.01 times 60 times 60. And that gives me, looks like 28,080. And let me just write that down. 28,080. 28,080. And it's not just 80, right? Because again, we got to look at our units. It's 20,000 or 28,080 meters per hour. That's a bad R. There we go. Okay. 28,080 meters per hour. Well, let's see if we got that right. Ooh, looky there. 28,080 meters per hour. We're on a roll. We only have 3 more. Okay, let's look at number 12 here. Okay, number 12 here. Convert 7.2 times 10 to the third power grams per liter to the unit centigrams per milliliter. Okay, so a lot of scary stuff. It always looks scary on the surface, but when we break it down, it won't be too hard. So first off, this is in scientific notation, which is kind of scary. No one likes to do math with scientific notation, present company included. And secondly, we have multiple units of measurement we have to deal with here, but that's okay. Let's just always start with what we know. Our question says that we have, I think it was I've already forgotten it. Oh my gosh. 7.2 times 10 to the third power. Okay, 7.2 times 10 to the third power. I think it was grams per liter. Yep, grams per liter. And again, I like to write this as such. I like to write it so I kind of have a good idea of what my numerator is and what my denominator is. It's grams per liter, so my grams is in the top and my liters is in the bottom. And I'm trying to convert this into, what was it, centigrams and something? Centigrams and milliliters. Okay, centigrams and milliliters. Well, okay, let's focus on centigrams, right? Let's focus on our mass and convert that. So that's a good first step, I think. Ew, that's a terrible line. Okay, that's slightly better, I guess. So yeah, I can do that. So we have grams and centigrams, right? We can figure out that conversion factor. First off, grams goes down here. And centigrams goes up here, right? Because they're always trying to cancel out your units. Okay, and we go to our metric prefixes table. And it looks like grams and centigrams. So centigrams, again, this will tell us how much of the base unit is in the prefix. So this is telling me that there are 0.01 grams in a centigram. Okay, there are 0.01 grams in a centigram. There's 0.01 grams in a single centigram. Easy peasy. Now, if we do this math, I'm not going to just yet, but if we were to do this math, if you'll notice, grams cancel, and look what we're left with. We're left with centigrams, which is what we're looking for in terms of mass. But we're not done because volume is not finished, right? So this is in liters, and we want it. Oh gosh, I've already forgotten. What do we want it in? Milliliters? We want it in milliliters, okay? So we want it in milliliters. So we're not done yet. We got one more step. Okay, we want this in milliliters, okay? Well, let's think about how this would work. All right, we have liters down here. So if we have liters down here, do we want liters up here or down here? Well, we're gonna want liters to go in the top because again, this is in the denominator, right? If this is in the denominator, we want our other liters to be in the numerator because we don't want liters. We're trying to cancel them out. But this way, it's like, you know, it's like something over 5 times 5 over something. Those 5s would cancel out, just like this. This is something over liters times liters over something. So those liters cancel out. And what are we trying to convert this to? I believe it was milliliters, right? So we're going to put our milliliters right down here. Right down there. Okay, now let's look at our conversion factor here. This tells us how many liters are in a milliliter. It looks like there are 0.001 milliliters in a liter. Okay, there are 0.001 liters in a single milliliter. Okay, now my liters will cancel out. And let's look at the 2 units of measurement I'm left with. I've got centigrams in the numerator and milliliters in the denominator. So whatever answer I get, whatever numerical answer I get, I know it's going to be expressed in centigrams per milliliters. And that's great because that's what I'm looking for, centigrams per milliliters. So let's just put this down here, right? I want a little bit of room. So let's just throw this all in the calculator here. We have 7.2 times 10 to the third power. Don't forget that times 10 to the third power, right? Because that's what the number is, 7.2 times 10 to the third power, divided by 0.01 times 0.001. Now I get, and I hope this is right, if not, I'm going to have to go back and redo this. I get 720. Oh, 720, centigrams per milliliter. Centigrams per milliliter. Let's see if that's correct. Oh yeah, 720 centigrams per milliliter. Look at us. Okay, let's look at 14. Convert the density 4.5 times 10 to the fourth power grams per meters cubed into the unit grams per milliliter. Oh geez, that looks like a lot of work. This is gonna be an annoying question, but let's just do it. I can't imagine you're gonna get a question like this on a test, but it's always good practice, right? Because if you know how to do the hardest ones, it means you'll always have no trouble with the easier ones, huh? Or at least that should be how it is. Okay, so again, well, let's just start with our number here. It's gonna be, I'm just gonna write this down off screen and then I'll show the screen, but it's going to be 4.5 times 10 to the fourth power grams per meters cubed. And we need to convert that into grams per milliliters. Okay. You know what? Actually, this isn't too terrible because if you look here, grams does not change, right? We start with grams and we end with grams. You know what that means? It means in terms of my mass, right, my grams, I don't have to worry about converting. All I have to worry about is this number right here. All I have to worry about is converting meters cubed into, what, milliliters, I think? Meters cubed into milliliters. So there's a couple different ways to do this. I usually just Google, cubic meters to milliliters. That's what I do. So I'm going to keep doing that. cubic meters and milliliters. The book does a little bit different. They do like a multi-step thing where they convert it to centimeters cubed and then milliliters. I don't really know why they do that. I think it's unnecessary extra math in my opinion, but I'm gonna do it my way. So, right, we know that there's 1 cubic meter in a million milliliters. So for every 1 million milliliters, that's 1 cubic meter. We can use that. Let's just throw that in. Let's throw that in our calculations. So I have meters cubed on the bottom, right? Which means I know meters cubed has to go on the top. Because I'm always trying to cancel out my units. If it's in the denominator, it goes in the numerator. If it's in the numerator, it goes in the denominator, right? Okay, and then what, so what I'm trying to cancel out is up here, right? So then what's gonna go down here, I wonder? Well, it's what I'm trying to find. And what am I trying to find? What's this question asking us for? I've already forgotten. Milliliters, right? Milliliters, so that's what's gonna go on the bottom, milliliters. Okay, and according to Google, 1 cubic meter is the same thing as 1 million milliliters, okay? So 1 cubic meter is the same thing as 1 million milliliters, okay? Kind of scrunch that in there. You can write it a little bit neater if you want. So if I do this math, my meters cubed will cancel. And then look what I'm left with. I'll be left with grams per milliliter, which is what I'm looking for, right? So let's do this math. It's going to be 4.5 times 10 to the 4th power divided by 1 million. So 4.5 times... Oh, and by the way, in your scientific calculator, there should be a 10 to the x power button, so you can always use that. But you can fiddle around with your calculator on your own time. But yeah, so 4.5 times 10 to the 4th power divided by 1 million. I get 0.045. I really hope that's right. .045 grams per milliliter. So you know what? Even though that question looked really scary, it actually took us less time to figure out than a lot of the other questions. I don't like the way that, well, whatever. So let's see if, let's see if we got that right before we celebrate, huh? Look at that. See, look what the book does. See how they do this extra step? I don't know why they do that. I don't think that's necessary at all. Whatever. Okay, we got one last question. Convert the volume 3.5 meters cubed to the unit liters. Remember that 1 milliliter equals 1 centimeter cubed. All right, well, since they're giving this information, I won't use Google since they're actually giving me the unit of measurement. And we'll see how that affects my answer. Okay, so I'm just going to write this down. 3.5 meters cubed. Oh, sorry. So I'll show you that. 3.5 meters cubed. Trying to convert it into liters. And it tells us that 1 milliliter is equal to 1 centimeter cubed. So I guess what it wants us to do is it wants us to first take our meters cubed and then convert it into centimeters cubed and then convert it into milliliters and then liters. So it's actually going to be a multi-step process. But that's okay. The thing is, when you just break it down like I'm doing, it's actually, it gets simpler when you just break it down. You just think, what's my next step? So I need to, again, the only way I can figure this problem out according to the information I'm given is to use their conversion factor. 1 milliliter equals centimeters cubed. So the first thing I need to do, sorry about that, is convert meters cubed into centimeters cubed. All right, so let's just do that. Let's set up my line here. And I know meters cubed is going to go on the bottom. All right, so, well, meters is going to go on the bottom. And I'm trying to convert it into centimeters. And I know that my metric prefix, well, remember, my metric prefixes, it doesn't tell us about cubed values. It just tells us about the basic one-dimensional value. So what I mean by that is if I'm trying to figure out, centimeters and meters, so this tells me that there are 0.01 meters, okay, 0.01 meters. in a single centimeter. Okay, 0.01 meters. That's a horrible zero. 0.01 meters in a single centimeter, right? Now here's the thing though, we're not talking about single dimensions. We're talking about a unit of volume, which is, length times width times height, or, this stuff cubed. So I have to take this entire value. I have to take these numbers, and I actually have to cube both of them. Okay, so I'm going to put them both cubed. That would also look like this. Okay, I'm just going to do it individually though, like this. Well, no, actually, I will do it like this, actually. Okay. Okay, and if I were to do that math, right, this would be 0.01 meters times 0.01 meters times 0.01 meters. That's like 0.00000001 or something. I don't want to do that just yet. I'm going to leave it as is. But I do know that if I were to do this, right, because there's a cubed here and a cubed here, these meters would cancel out, which is great, right? The meters would cancel out, and I'd be left with centimeters cubed. But I don't want centimeters cubed. We're not done yet. This is probably the hardest question, I think, on this. But, right, because it's asking us to convert this into liters. And the first thing we have to do is, well, we just converted things into centimeters, right? Now that we know what our value is in centimeters, we can convert it to milliliters and then convert milliliters to liters. Okay, so that's our next step. And this actually is pretty simple, right? Because this is a 1-to-1 ratio, right? 1 milliliter equals 1 centimeter. Now I am going to write this down, but you'll see that there's no math we have to do here, right? I will write this conversion factor down, but it will not really matter. Okay, now according to our book, I'm going to put centimeters down, or centimeters cubed down here, right? And milliliters? Is that what it was? Milliliters, yep. I'm going to put milliliters up here. And according to this book, right? According to this book, 1 milliliter is equal to 1 centimeter cubed, or 1 cubic centimeter. So I'm just going to put that. 1 milliliter is equal to 1 cubic centimeter. Do I have to do any math there, right? 1 and 1. There's no actual math I'm doing there, but I did want to write it down to show you that my centimeters cubed will cancel out, and I'll be left with milliliters. So I'm almost done. There's only one last step. If I were to do this math, I'm not going to do it right now, but if I were to do this math, my final answer would be in milliliters, right? And I don't want it in milliliters. I want it in liters. So I have one last step. I need to convert milliliters to liters. Well, again, I have milliliters right here, okay? So I want to convert that into liters. So I'm going to set it up like this, right? Whatever you're trying to cancel out goes on the top, or I'm sorry, whatever you're trying to cancel out goes on the opposite side. So milliliters is at the top, milliliters goes at the bottom. And I'm trying to convert this into liters. So let's look at our prefix table, and it looks like there are 0.001 liters in a single milliliter, okay? There are 0.001 liters in a single milliliter. You could also say there's like 1 liter over 1,000 milliliters. It would be the same stuff. I'm just using what the table tells me. That's all. Okay. Now, if we look here, look at all these red crosses I've drawn because I'm trying to, keep track of my centimeters and meters and all that jazz. My meters cubed canceled out over here. My centimeters cubed canceled out over here. And my milliliters canceled out here, leaving me with liters. So whatever answer I get, and I'm just going to put that over here, whatever answer I get, that is going to be in liters, which is what the question's asking for. The only tricky thing about this math is, remember, right here, this value right here, this is 0.001 or 0.01. Remember, that's still being cubed, okay? So just keep in mind when you do this math, it's going to be 3.5, or is it 3.5 times 10 to the something power? I don't remember. Nope, just 3.5. It's going to be 3.5 divided by, and this is important, it's divided by 0.01 cubed, okay? 0.01 cubed. Times 1 divided by 1, who cares about that? Times 0.001, okay? Times 0.001. And you should get oh, I hope I did this right. I don't want to have to redo this question. Should get 3,500, right? Should get 3,500 or 3,500 liters, right? Don't forget to put your unit of measurement. That's the whole reason we did all this, is to get our correct unit of measurement. So 3,500 liters. Let's see if we got that right. Oops. Let's see. So they put 3.5 times 10 to the third power. That is the same thing. Okay, that is the exact same thing, and I'll show you why. I don't even know why they did that, but here, I'll show you. I'll show you that in the scientific notation. If I were to put a decimal here and go 1, 2, 3, right? 1, 2, 3. That would be 3.5 times 10, and you just look at how many spaces we counted. We went 1, 2, 3, so it's times 10 to the third power liters. So that is the same answer. Okay. All right, that took me just under an hour, so this better have help. This is better help. Okay. So those are the 8 questions that we went over. I hope after doing this you have a better understanding of converting units. I hope you're not even more confused than you were, but good luck.